In this video, we are going to evaluate the following integral by substitution method. We are going to evaluate the following integral by substitution method. Now, example 1 here we have, question 1 here we have integral of 3x plus 4 all cubed dx. We have to evaluate this integral, and by evaluating this integral, we are going to let the inner function, which is u, let the inner function be u. The inner function is 3x plus 4. Let the inner function be u, and if we let the inner function to be u, that means we are going to be left with integral of u raised to the power of 3 dx. So let's differentiate u with respect to x. We are going to have 3 dx, and that means the x will be equal to du over 3. So this is going to give us integral of u raised to the power of 3 du over the 3. Now we can actually bring this 3 outside. We are going to have u raised to the power of 3 du, and if we integrate this, we are going to have u raised to the power of 4 divided by 4 plus c. And then inputting back our value of u, we are going to have 3x plus 4 raised to the power of 4 divided by 4 plus c, and this generally is going to give us 3x plus 4 all raised to the power of 4, this is 4 here, all raised to the power of 4 divided by 12 plus c. So this is our integration of that function. So let's look at our example 2 here. Now we have our inner function to be 2x plus pi. So let u be equal to 2x plus pi. Now if we differentiate 2x plus pi with respect to x, the u will be equal to 2 dx. Of course, pi here is a constant, so it's going to give us 0. So now we have the x to be equal to du over 2. The x is equal to du over 2. So that means this I now will be equal to integral from 0 to pi over 2, and we'll now have sine u. And instead of having dx now, we are going to have du over 2. So since we are solving this in terms of u now, we are going to change our limit. Now we change our limit, so that means when x is equal to 0 from the lower limit now, u is equal to 2 multiplying 0 plus pi, and we have this to be pi here. So 0 is pi, the lower limit will now turn to pi, and when x is equal to pi over 2, u is equal to 2 multiplying pi over 2 plus pi, and 2 will divide 2 there. We are going to have pi plus pi, which is going to give us 2 pi. So now our limit will change. Our limit will change from pi to 2 pi, and this will now be sine u du. 1 over 2 is outside there. So now let's integrate this. Integrating sine u is going to give us minus cos u. So let's put the minus outside. 1 over 2. We have cos u here, and we are taking our limit from pi to 2 pi. Now when you are integrating definite integrals, there's no need to put your constant, because your constant will turn to 0. So this will now be, implies that we have minus 1 over 2 outside there, into substituting our upper limit. Now we are going to have cos 2 pi, and cos 2 pi will give you 1 minus, substituting our lower limit, we are having cos pi, which is cos 180, it is going to give us minus 1, and we will now be left with minus 1 over 2 times 2, and this is going to be minus 1. That is our answer. Our answer is minus 1. Now let's look at our third example here. Here let's substitute u to be equal to x cubed plus 3x plus 3, and so this means that this integral will become x squared plus 1 divided by u raised to the power of 1 over 2. The square root of u is the same thing as u raised to the power of 1 over 2. So now if we differentiate the u with respect to x, we are going to have 3x squared plus 3 dx, and making dx the subject of the formula, dx will be equal to du all over 3x squared plus 3. So this integral will now become, this is dx here, x squared plus 1 divided by u raised to the power of 1 over 2. Instead of putting dx, you are going to have the u all over 3x squared plus 3. So that is what we have. Then at this junction now, you discover that we can factorize 3 here in the denominator here. We can factorize 3 out in the denominator there, and that means we are going to have integral of x squared plus 1 divided by u raised to the power of 1 over 2 multiplying 3 into x squared plus 1 du. So that means we now have x squared plus 1 here, and we have x squared plus 1. So this will divide this. So we'll be left with integral of 1 divided by u raised to the power of 1 over 2, and we have 3 here, and this is the u. So that means 1 over 3 can go outside, and you'll be left with 1 over u raised to the power of 1 over 2 du, and you also have 1 over 3 integral of u raised to the power of minus 1 over 2 du. So this becomes more easy now. You have 1 over 3 multiply u raised to the power of minus 1 over 2 plus 1 divided by minus 1 over 2 plus 1 plus c, and this will give you 1 over 3 multiplying u raised to the power of 1 over 2 divided by 1 over 2 plus c, and your final answer is going to be 2 over 3 square root of u plus c, and this is your integration of this. So we now go to example 4. So in our example 4 now, let u to be equal to 2x minus 5, the denominator. Then differentiating this, the u we have 2 dx. That means the x will be equal to du divided by 2. Now our integral will become integral of 7 divided by u times du over 2. Then 1 over 2 will come out. 1 over 2 will come out. You have 7. This 7 can also come out. So let's put the 7 also outside. You have 7 divided by 2. Then you have 1 over u du. In differentiating ln, we are going to have this to be ln u. Differentiating 1 over u, we are going to have ln u plus c, and this will now be equal to 7 over 2 ln u. We have u to be 2x minus 5 plus c, and this is our integral for that function. That is our answer. Now let's look at the example 5, where we let u to be equal to 2 plus 5x, and in differentiating 2 plus 5x, the u will be equal to 5 dx, and that means dx will be equal to du all over 5. So this integral will become, we can bring this 6 outside actually to become sec square u. Instead of putting the x now, we have the x to be du over 5. And this could also become 6 over 5 integral of sec square u du. In integration of sec square u, we have it to be tan u. Remember, integration is reverse of differentiation, and we have d du of tan u to be equal to sec square u. Then it means the integral of this will also give us this because they are reciprocal. Now we now have this to be 6 divided by 5. Integrating this, we have it to be tan u plus c. So this is 6 over 5, and this is tan. Instead of having u, our u was 2 plus 5x plus c, and this is our integration. Please like this video, share with your friends. I would love to know what you think about this video in the comment section below, and don't forget to subscribe to this YouTube channel and hit the notification bell to get notified each time we upload a video. Thank you.